In Precalculus, section 2.2, we're dealing with polynomial functions. So it's sums and differences of monomial functions. So last section you dealt with monomials. And the polynomial graphs do not have breaks, holes, gaps, or sharp corners. So if you see a graph with any of those, then it is not considered a polynomial. So determine all the real zeros. So if you remember from our previous sections, zeros of an equation is the same thing as the x-intercept, right? So what I would do is if I'm looking for the x-intercept, then I have to put 0 in for the opposite. So I put 0 in for y, and now I have to solve, okay? So in this case, I do x cubed minus 5x squared plus 6x. I have, these all have an x that I can take out. So then I end up with x squared minus 5x plus 6. Then from here, I can put, because this is a squared, this is all equals 0, I do x. So x, two numbers when multiplied together gets me 6, but when added together gets me -5. I'm thinking it's -6. Two numbers when multiplied together gets me, so -2 and -3. So now my answers are, so this tells me how many answers there are. So we have x equals 0, because if this is 0, the whole thing's 0. If this is 0, the whole thing's 0. This is 0, the whole thing's 0. So my options are x equals 0, 0 equals x minus 2, and 0 equals x minus 3. So we have 2 equals x and 3 equals x. So our answers are x equals 0, x equals 2, and x equals 3. These are our two zeros. So let's check it. This is the equation that's graphed right here. We have x equals 0, that's the first intercept. X equals 2, this is 1, 2, second intercept. And then x equals 3 is the third. So those are in fact our zeros. Now they're not always going to give you a graph to look onto it, but this is a nice comparison to find our zeros. So pause and write this down. So we can move on to the next board. Now, a quadratic form of a polynomial is au squared plus bu plus c. So we're trying to manipulate an equation to quadratic form to help you solve. So we're doing the same thing. We're trying to find zeros. But on this one, we were lucky enough to be able to take an x out to get us there. We're experts at being able to solve quadratic equations, x squared, right? You did last year in Algebra 2, you did multiple sections and multiple chapters on just how to solve squared. Now, what we're doing is they're now giving you ways that you can manipulate the equation so that you get a quadratic form of the polynomial so that you can apply the same rules. And what that means is I can rewrite this any way as long as I don't change anything. So if I change x to the 4th to be x squared, the same thing, I'm just rewriting it. Now bear with me. And the -4, if this is x squared, this is the same thing as saying x squared plus 3 equals 0. Because I'm putting 0 in for this because I'm looking for the zeros. Now what this is saying is that I found this value u, right? So my u is x squared. You're going to be doing a lot of this in calculus, is manipulating and creating a way so you can use methods to solve other higher up problems. So my u is here, x squared, x squared. So then I can rewrite this to go u squared minus 4u plus 3 equals 0. This is something that we can solve, right? The only thing is I replace x squared with this. I will put it back later on, but right now I'm just going to focus on this. again, we're taking a big problem like this and we're just breaking it down into chunks so that we can use methods, so we don't have to learn a whole bunch of new methods, we can use these methods. So here, it's the same thing we did when we're solving, right? U. Two numbers when multiplied together gets me 3, but when added together gets me -4. We would do -3 and -1. So then I would continue to solve this, but first, let's then put back our x squared. So we have x squared minus 3, and then x squared minus 1. What did that do? Well then, it did put us have these squares, but now they're a lot, I can now solve these a lot easier than I can just solve this, because I've broken it down. So I know that x squared minus 3 equals 0, and x squared minus 1 equals 0. So then I'm going to add 3 to both sides. I end up with x squared equals 3, and then square root, so x equals plus or minus 3. The next one, plus 1 on both sides. X squared equals 1. Square root both sides, I end up with x equals plus or minus 1. So my answers are, and I should have 4, plus minus 3, which is positive 3, negative 3, and plus and minus 1. So I can do 3, negative 3, 1, negative 1. I don't care which way you write it, as long as you understand that it represents 4. So if we were to graph this, it would hit, and it would hit on -3, then 3, sorry, -3, then -1, then then positive 1, then positive 3. So go ahead and pause and write this down. The next one we're going to do is a combination of both, okay? And I'll tell you what I mean. So for number 3, I could try the last state, not a combination of both, sorry. I could try the whole, because I see the x4, and try to manipulate it. But if they all have something in common, always check. The first step to do is always check to see if you can find any common factors. Now the coefficients don't have a common factor, but my x's do. Not only can I take out one x, but I can take out at least an x squared, 2 x's, which would then give me an x squared plus 5x plus 6, right? Equals 0, because I'm trying to find the zeros. I end up with x squared, and then 2 numbers when multiplied together gets me a positive 6, but when added together gets me a positive 5. But when added together it gets a 5, so that's positive 2 and positive 3. So now I do x squared equals 0, then x plus 2 equals 0, then x plus 3 equals 0. I square root both sides, I end up with x equals 0, or plus or minus 0, so 2 zeros. And then minus 2, I end up with x equals -2 and minus 3. X equals -3. Now, my zeros are 0, -2, -3. There's a repeat on 0, because there's 2 of them. We have x squared. But 0, -2, -3 are the equations. Your answer. So hopefully those methods can help you manipulate the equation to use things that you can use to solve quadratic equations instead of dealing with higher order numbers. So try the guided practice number 3A, 4B, and 5B. 3A, 4B, and 5B. And also use your graphing calculators to check to see if your zeros are on point. Okay? Pause and write this down, try the problem, and I will see you in class.